friends, are you at the last minute preparation for your KCET? Here is a video on one of the most important topics of KCET examination, that is electric charges and fields. What are you thinking about? Grab a book and note down the questions. Let us get the solutions together. Look into the first question. An electric dipole is placed at an angle of 30 degree with an electric field of intensity 2 into 10 to the power of 5 Newton per coulomb. It experiences torque equal to 4 Newton meter. Calculate the magnitude of charge on the dipole if the dipole length is 2 cm. According to the question, let us note down the given data. The dipole is inclined at an angle theta, that is 30 degree here, and the dipole is in the presence of electric field as told. Let us say this is the electric field in which the dipole is present. This is our dipole with the charge plus q and minus q. Charges are equal and opposite to each other, separated by some distance. What is the electric field intensity E? It is 2 into 10 to the power of 5 Newton per coulomb. It experiences a torque equal to, the value of torque is given. It is Newton meter. Calculate the magnitude of charge on the dipole. Here we have to calculate magnitude of charge, in the sense the value of Q needs to be calculated. Q is what we have to calculate. If the dipole length is, they have given the length of the dipole, which we usually write as 2a. Some of you will write as 2l, some of you write it as 2x, whatever. We are going to write it as 2a as the length of dipole, which is equal to 2 centimeter. It needs to be converted into meter. How do we convert it? We just have to write 2 into 10 to the power of minus 2 meter. Here we have to find the value of Q with the data given. One of the formula that I have here is torque tau is equal to P cross E. Torque is the cross product of dipole moment and electric field. So where is the dipole moment here? Dipole moment is from negative charge to positive charge, this way. So here is our value theta. You can also write tau as PE sin theta. For finding the value of P, we are going to use this formula. Why? Because there is an expression that relates charge and dipole moment. What is the expression? It is P is equal to Q into 2A. Since we are given with the 2A, and calculating the value of P makes us to find Q. That is why we are going to use this formula to find P. I'll rearrange it. P is equal to tau by E sin theta. What is tau? That is our torque. So torque is 4, here I have not written, torque tau is 4 Newton meter. 4 by electric field intensity here is 2 into 10 to the power of 5 sine of an angle theta, that is sine 30 degree. I can also write this as 4 divided by 2 into 10 to the power of 5 sine 30 degree is half. That leads us to the answer for P as 4 into 10 to the power of minus 5. What is the unit for dipole moment? It is coulomb meter. Hence we got the value for dipole moment. We are going to use this formula, this value of dipole moment in this formula. That is Q is equal to P by 2A. I am rearranging it. P is 4 into 10 to the power of minus 5. 2A is 2 into 10 to the power of minus 2. The answer here is 2 into 10 to the power of minus 3 coulomb or 2 millicoulomb. What is the correct answer? The correct answer is option D. We'll move on to the next question. A polythene piece rubbed with wool is found to have negative charge of 4 into 10 to the power of minus 7 coulomb. The number of electrons transferred from wool to polythene is. So here we have two pieces. One piece is of polythene, the other piece is of wool. So both of them are rubbed over each other. Polythene piece is rubbed with wool that is found to have negative charge. Polythene is going to have a negative charge, that is 4 into 10 to the power of minus 7 coulomb, which also means that electrons from wool got transferred to polythene and hence it became negatively charged and wool became positively charged. Hence, a polythene became a charged body. What is the charge on polythene? It is Q is equal to minus 4 into 10 to the power of minus 7 coulomb. Since it has got negatively charged, I have written this negative sign. We have to calculate the number of electrons that gets transferred from wool to polythene. How many number of electrons got transferred? The value of N needs to be calculated. What is the charge on each electron? Charge on one electron is given by, I'll write E is equal to minus 1.6 into 10 to the power of minus 19. So, what do we have from quantization of charge? Q is equal to N into E. Charge on a body is integral multiple of charge on an electron. That is our total charge Q. We have to find the total number of electrons that got transferred from wool to polythene. It is N is equal to Q by E. Q here is minus 4 into 10 to the power of minus 7. Charge on an electron is 1.6 into 10 to the power of minus 19 coulomb. What answer we are going to get here? Simply I can write this as 40 by 16 into 10 to the power of, it is 12, right? The answer that we are going to get here is 2.5 into 10 to the power of 12 electrons. These many number of electrons got transferred from wool to polythene. I hope you are clear with this. The correct option here is option B. Before I move on to the next question, subscribe our channel for more such videos. According to Gauss theorem, electric field of an infinitely long straight wire is proportional to. According to Gauss theorem, there is infinitely long straight wire which is a charged one. The wire is of infinite length. We are going to imagine a Gaussian surface, that is a cylindrical Gaussian surface around it. What was the expression that we had got from this derivation done earlier? What is the electric field at the point P? Electric field at the point P, which is at a distance r from the wire. What was the expression? It is simply E is equal to 1 by 2 pi epsilon naught lambda by r. What is r? Lambda here? Lambda represents linear density of charge. Linear density of charge. I can also write lambda is equal to charge per unit length. So this was the expression we had derived. And the expression is about electric field at a point near an infinitely long straight uniformly charged wire, and that was obtained using Gauss law. I'm not going to derive an expression here. The expression is already written directly. What you can see here is E being proportional to 1 by R, where R is the distance of the point from the wire we have taken, right? So E is directly proportional to 1 by R. The correct option among the four given options is option D. Clear? Let us move to the next question. An electric dipole has a pair of equivalent opposite point charges Q and minus Q separated by a distance. The axis of the dipole is defined as. Here simply we need to remember what is a dipole. A pair of equal and opposite charges separated by a small distance. I'll write 1 plus Q and 1 minus Q charge that is separated with the distance 2e. And we call such a setup is of dipole. What do you mean by dipole moment? Dipole moment is the product of magnitude of either charge. One of the charges magnitude I have to take. And the dipole length is 2e. That is known as our dipole moment, which is our vector. P cap represents the direction of this vector P. What is the direction of this dipole moment? It is from negative charge to positive charge. This is the direction. Hence I'll write vector P to be from negative charge to positive charge. This is what we know and we have already studied about it. Let us look into the options to find the correct option from the given four options. Direction from positive charge to negative charge? No, it is not. Direction from negative charge to positive charge? Yes, it is. Here is our correct option. If we look into other options, perpendicular to the line joining the two charges drawn at the center and pointing upward direction. No, it is not. Option C is wrong. Perpendicular to the line joining the two charges drawn at the center and pointing downward direction. That is also not. Hence option B is the correct one. Question number 5 says, three charges each of plus 1 microcoulomb are placed at corners of equilateral triangle. If the force between any two charges is F, the net force on either charge will be. Here we have to determine the net force. Let us think of three charges being at the corners of an equilateral triangle. What is the angle for an equilateral triangle? All the angles should be equal as told. That is why the angle here I am going to take is 60 degree. And the charges are present here. 1 microcoulomb plus 1 microcoulomb and 1 microcoulomb. So there will be two forces. The force between this 1 microcoulomb and 1 microcoulomb will be repulsive. Let us say the force of repulsion, here it is F, I'll write it as F1. Okay. Here the force due to this 1 microcoulomb charge and here 1 microcoulomb of charge is there, right? They will again repel because the charges are of same kind. Hence the force here is F2. I'll write that force as F2. Both the forces are F1 and F2. What is the question? What is the net force on either charge? So here we have to determine the value of net force. What is the angle between the force? Once again it is equal to 60 degree. Net force on either charge needs to be calculated, right? So we are going to use this formula to find the net force, that is by using the principle of superposition. Using principle of superposition, What do we have for the expression of net force or the resultant force? It is F equal to root of F1 square plus F2 square plus 2F1 F2 cos of an angle theta. What is the value of theta here? Angle between these two forces F1 and F2, these two vectors, is equal to 60 degree, right? Then what about the value of these two forces? Do you think they are being equal? Yes, the forces here are equal. Why? Because these are the forces due to all equal charges. Also note that F1 is equal to F2. We'll note it down as F. Hence, we are going to write F square plus F square plus 2F into F as F square once again cos 60 degree. What is cos 60? It is half, right? So I'll write root of 2F square plus 2F square into 1 by 2. Here 2 and 2 gets cancelled. We are left with root of 3F square. It can also be written as root 3 into F. What is the net force? Net force is root 3F. Where is the correct option? Here is option B, that says F root 3. I hope you are clear with this. Make a note that this chapter is the most important one and you can expect about 5 questions from this chapter. Watch full videos to solve all the questions. If you want to watch the chapter-wise weightage of KCET 2025, there is a video in our channel, you can refer it. The electric field at a point on an equatorial line of a dipole and direction of the dipole moment. So once again, we have to consider a dipole with the charge plus q and minus q, and here is our dipole moment P. What is the point along the equatorial line needs to be? It is a line that divides the dipole exactly half. That is why it is called as an equatorial line, and it should be perpendicular. This is the equatorial line and the point P needs to be taken over it. What is the electric field at this point? What should be the direction of electric field? The resultant electric field is in this direction. This is our resultant electric field, and we have also obtained the expression for electric field with the help of a derivation, right? So the question is related to this. What is the direction of electric field and electric dipole moment? We have to understand the question carefully because it might confuse us. The electric field at a point, we have it here on equatorial line of a dipole. Yes, it is on equatorial line of a dipole. And direction of dipole moment, they are asking the direction of dipole moment and electric field, how they are along the equatorial line. Along the equatorial line, they will be perpendicular. Electric field is perpendicular to this equatorial line. Electric dipole moment is also perpendicular to this equatorial line. Hence, option C is the correct one. Next question number 7. The dimensional formula of electric intensity is. What is the expression for electric intensity E? It is nothing but F by Q. Or I can also write it as MA by, what is Q? I into T, right? Since I is equal to Q by T and force is the product of mass into acceleration. Dimensional formula for mass is M. Dimensional formula for acceleration is L T power minus 2. Dimensional formula for current I is A. Dimensional formula for time is T. Hence, what is the proper dimensional formula? ML A power minus 1 T power minus 3. Dimensional formula for electric field intensity is option B. Let us read the question number 8. Two small conducting spheres of equal radius have charges plus 10 microcoulomb and minus 20 microcoulomb respectively are placed at a distance from each other and they experience force F1. If they are brought in contact and separated to the same distance, they experience force F2. The ratio of F1 to F2 is. So let us draw the relevant diagram for the given question. There are two spheres. They are of different radius. And the charges, there are two spheres. They are of equal radius. Radius of them is the same. What is the charge? It is plus 10 microcoulomb and minus 20 microcoulomb. They are placed at certain distance. Let us note down that distance as r. R is the distance of separation between them. Okay. So they are going to experience the force F1. There is a force of attraction between them, right? Both the forces, both the charges are opposite in their magnitude and hence the force experienced by them is attractive. Hence we are going to apply Coulomb's law here because the force is being attractive, right? What do we have from Coulomb's law? It is simply written as F equal to K Q1 Q2 by R square. What is F? That is the force F1 here. K is written as it is. I am not going to write the value of K. What about Q1? Q1 and Q2 are nothing but the charges. Q1 is plus 10 microcoulomb. Q2 is minus 20 microcoulomb. Right? So what I am going to write here, the value of Q1 as plus 10, Q2 minus 20. What about R? Let me write that R as the radius of the sphere. R being the radius of sphere. Right? Now I can write the expression for force as F is equal to K into minus 200 divided by R square. This is when the charges, when the spheres are separated with a certain distance r. Then what is done? Both the spheres are brought into contact. Both the spheres were touched with each other. What happens when they are in contact? When the spheres are together, since they are of same radius, the radius are the same here, right? Their charges will be shared with each other. What happens to the charge here? It becomes Q1 plus Q2 by 2 on separation test. For the other sphere, the charge is again Q1 plus Q2 divided by 2. The charges got equally distributed and hence the charge on each sphere will be Q1 plus Q2 divided by 2. What is Q1? It is plus Q2 will be minus 20 divided by 2 and hence it is minus 5. It is minus 5 microcoulomb of charge on each spheres. Each spheres have got the charge as minus 5 microcoulomb and the distance of separation remains the same. So they are going to experience the force. What is the force between them? Now you can see that the force of repulsion will be between them. The force will be repulsive. Right? So F2 is the force of repulsion. Hence I'll write F2 is equal to K into minus 5 into minus 5 divided by R square. That is the radius of this sphere. So what are you going to get here? It is k into 25 by r square. So the forces are F1 and F2 that were calculated. What do we have to find is the ratio of forces. What is the ratio of F1 to F2? I'll write F1 by F2. What is F1? I can directly cancel here. K cancels. R square cancels. F1 is minus 200. F2 is 25. You are going to get minus 8 by 1. F1 is to F2 is equal to minus 8 is to 1. The correct option here is minus 8 is to 1. Subscribe our channel for more such videos. The electric dipole moment of an electron and a proton 4.3 Newton meter apart is. There is an electron and a proton. Which are the charges? They are separated with the distance of 4.3 Newton meter. What do we have to find here is the electric dipole moment, and here is the direction of dipole moment P. So dipole moment P is the product of magnitude of either charge and the distance of separation between them, right? So what they are given with this 4.3 Newton meter is nothing but the distance of separation between the charges. We have 2a as equal to 4.3 Newton meter, nanometer, 4.3 nanometer. I can also write this as 4.3 into 10 to the power of minus 9 meter. So substituting the value here, what about the charge here? Magnitude of either charge, it is one and the same, right? 1.6 into 10 to the power of minus 19 coulomb. I can write P is equal to 1.6 into 10 to the power of minus 19. 2A is 4.3 into 10 to the power of minus 9. What are you going to get as the value of P? It is 6.88 into 10 to the power of minus 28 coulomb meter. Hence the correct answer is option A. Question number 10, that is the last question for today. Acceleration of an electron in an electric field of magnitude 50 volt per centimeter if E by m value of electron is 1.76 into 10 to the power of 11 coulomb per kg is. So what is given in the question? We have to write. Acceleration needs to be calculated. Acceleration of an electron. Electric field here is 50 volt per centimeter. You can also write this as 50 into 10 to the power of 2. Centimeter is 10 to the power of minus 2. It can be written as 10 to the power of plus 2 volt per meter. E by m value is given as 1.76 into 10 to the power of 11 coulomb per kg. Right? Now we have the formula, that is the force exerted on the charge QR as Q into E, or we know that E is equal to F by Q, right? Or F is equal to Q into E. What do we have to determine here is the value of acceleration. If force experienced by the charge is F, m is mass and a is acceleration, then we have E. What is the value of Q here? It is nothing but E, because it is the charge of an electron. One electron it is to, that is why it is E into capital letter E. Acceleration is equal to E by m into E. What is E by m value? It is 1.76 into 10 to the power of 11 Value of electric field is 50 into 10 to the power of 2. What are you going to get as the value of acceleration? It is 8.8 into 10 to the power of 14 meter per second square. Hence, option A is the correct option here. I hope you are clear with these solutions given. Subscribe our channel for more such videos. Also share with your friends and it will be helpful for them. And I'll be coming with more such solutions of KCET in my next video. Thank you for watching.